guys, this is Nandesh from Maja Physics, and in this video we are looking at one more important application of this free body diagram. So the system is the Atwood's machine. Let me draw it. So Atwood machine, so I'll be taking a rigid support and assume that this rigid support is provided with a pulley. So pulley is frictionless, it is not providing any frictions, and there is a string. Okay, the string is massless and assume that it is also inextensible. Okay, this pulley is passed over the string is passed over this pulley, and both the ends of this string are connected, or it is attached with two blocks of different masses. Let me call this block of mass m1 and the another block of mass m2. So one important thing that we have to understand here is, on both the sides of the suspension from the pulley there is a tension in the string, and this tension on both the side is exactly equal. So let us understand how this tension on both the sides of the suspension is equal. Okay, for that you can imagine that the system is in a different way. So assume that these two blocks, okay, this is a block m1 and block m2 or something like this, and this is the string which is connecting both the blocks, and the whole system, assume that it is resting on a horizontal smooth surface. Okay, so here we can also, if I apply a force on this m1 towards the left side, and assume that the force is equal to its weight, m1 into g. Similarly, we can also apply a force on m2 towards right, and assume that that force is also equal to its own weight. That means it is m2 into g. So depending upon which force is greater in magnitude, the entire system is going to accelerate with acceleration is equal to a. Assume that this m2g is greater than m1 into g, therefore the entire system is going to accelerating in this direction. Assume that the acceleration is equal to a. Okay, so now here when the system is accelerating in that direction, distance between these two blocks is not going to change. It is because I told you already that the string which is connecting the block m1 and m2 is inextensible and massless. But when you pull this m2 with a force equal to its weight, m2 into g, this m2 is actually pulling this m1 with a force. Let me call that force as tension, okay, which is acting through this string only. So that force I can write in this direction, let me call it as t. But still the distance between this m1 and m2 is not changing, which means this m1 is also exerting the same force on m2 through the same string. So therefore that force can be imagined in this way. So let me call that as t itself, and because the tension through the string are exactly equal but acting in the opposite direction, there is no relative displacement between the two blocks m1 and m2, and hence there is no relative velocity between them. Okay, so now here if I can imagine the same system over here, the only difference is the string is straight here, but here the string is going to be taking a curved path because of this pulley. Okay, so as you can assume that in the same way as before, this tension T is going to be the pull which is exerted by m2 on m1. Okay, similarly this tension is nothing but the pull exerted by m1 on m2. Because these two tensions are equal, this string is going to be inextensible. The length of the string is not going to change. So that is why I hope you understood why this tension is going to be same exactly. Now by using free body diagram I can explain, or I can derive the formula for this tension and the acceleration of the system as well. So let us derive these two formulas. I am not going to derive it, but I will simply show you how to obtain this tension and acceleration as well. Okay, so for that assume that this m2 is greater than m1, which means the force of gravity on m2, that means the weight, is going to be more when compared to the weight of this m1 into g as usually. And because of this force, this weight is greater than m1 into g, this system is going to accelerate in the downward direction. I mean, m2 is going down with the acceleration a, and m1 is going up with the same acceleration. Okay, so now write the free body diagram for m1 and m2 so that I'll get what is this t and what is acceleration. Okay, for that let me write the free body diagram of m1 first. So let me write m1 here. So on m1 we can see only two forces are acting, one is tension and the other is the weight of its block. Therefore tension in the upward direction and weight acting over here, let me call it as m1 into g, and we can write the dynamic equation for this free body diagram picture. Because t is greater than m1 into g, this m1 is going in the upward direction with the acceleration equal to a. So therefore I can write this t minus m1 into g is equal to, so what I can write is, it is m1 into a. So let me call this as equation number 1. And similarly, if I write the free body diagram for this m2 as well, so I can write like this. Assume that this is the block m2 and on which we have two forces. Once again, one is weight, so m2 into g, and the other is the tension acting on this same block. Let me call this is t itself. So the dynamic equation for this free body diagram is going to be m2g minus t, that will be equal to this acceleration. Okay, so I mean the total net force acting on m2 is going to be m2 into a, so which is the result of these two forces in the opposite direction. Therefore it is m2 into a. Let me call this as equation number 2. So here one important thing that we have to understand here, that the tension is always acting towards the point of suspension. Okay, it is always away from m2 and m1 in the system, that is the tension is always acting toward the suspension. So here more than directions, we have writing the equations on the basis of which is greater in magnitude and which is less in magnitude. So accordingly we have written the equations. So when you solve these two equations, number 1 and 2, so we can obtain what is t and what is acceleration of the system, that means a. So let me write, on solving these two equations, equation number 1 and 2, I can get the tension or the acceleration. So that tension is going to be 2 times m1 m2 divided by m1 plus m2 into g. So this is going to be the tension, and similarly the acceleration, I mean with which the entire system is moving, that is going to be m2 minus m1 divided by m1 plus m2 multiplied by g. So this is what the two important things that we have to solve, and I hope you understood how to write the free body diagram for this Atwood's machine or the pulley based. I hope you understood the concepts. Please give thumbs up and don't forget to subscribe. Click on the bell button to receive all the notifications, and thank you for watching.